John Carmack is a legendary games developer who has contributed immensely to the growth of this great industry. And I wanted to talk about him today, not just because I find him fascinating, but because he recently did a 5-hour interview with Lex Fridman, which is an absolute goldmine of insightful thoughts, lessons from the early days of id Software, and conversations about complex problems. During this 5-hour conversation, Carmack brought up some interesting tidbits about how he works and approaches problems. Specifically, there are two of them that I wanted to discuss in today's video that I think all programmers can benefit for, but I find particularly relevant for programming with Unity's entity component system. So I figured with today's video I could talk about these topics a little bit more in depth and then actually show you how to implement these quickly in an ECS project. Also, just wanted to give you a quick reminder that you only have a few days left to pick up the Ultimate Fantasy Unity RPG Developer Humble Bundle, which is put on by my friends Andrew of Infinity PBR, as well as Jason Wyman. It is a pay what you want Humble Bundle, and if you pay $30, which is the highest tier, you get a whole bunch of high fidelity and low poly assets from the Infinity PBR collection, as well as some tooling from the Infinity PBR team. You'll also get a 10% off coupon to use at the Unity Asset Store. Not only that, you will get access to Jason Wyman's game architecture course, which he normally sells for $1,000. So I may be a little bit biased because these are my friends and that's an affiliate link down in the description below, but I definitely think this is the best deal in game dev right now, so go check it out. Okay, so let's get into the two tips that I picked up from the John Carmack Lex Fridman interview. So the first one is to use debuggers as much as you possibly can. Carmack's main point here is to just say to not rely on your head to reason about what a programming is doing in certain situations. The only way to be sure is to let the computer actually do it. Using debug tools, you can easily follow along with the code stack and inspect variables along the way. Plus, it's a whole lot easier and cleaner than putting a bunch of temporary debug statements, everywhere throughout your code, which I'm definitely guilty of, by the way. Carmack, in this interview, he actually stated that every time he writes some new bit of code, he'll put a breakpoint at the beginning of that new section of code, and then he'll actually just step through it using the debugger just to make sure that the computer is actually doing what he thinks it's going to be doing, and it's modifying data along the way. This becomes especially important as we start to have more and more systems in our game and things start to get more complex and intertwined. We really need to understand, what the computer is doing in what order to avoid many major headaches down the line. I do just want to real quickly just kind of show you briefly how to do this and how to do it specifically in Unity ECS, because there are a couple things that you do need to watch out for. Okay, so we're going to start over in our IDE. Typically, you're going to link up your IDE over to the Unity editor. So I'm using JetBrains Writer. Of course, this is still very much possible in Visual Studio. In Writer, you just go ahead and click this little button that says attach to the Unity editor, and then back over in Unity, if you haven't done this before, it may just pop up with a little window that says, do you want to enable debugging? And you can just say, yes, I want to enable debugging. And then just to 100% confirm that you are connected, down in the lower right hand corner, you will see this little bug with a check mark here. And then when you hover it says debugger attached. That's how you know that the connection between your IDE and the editor has completed. So anyways, I'll just come back over here to the IDE, and now we can set up what is known as a breakpoint. So in this case, I have, from one of my previous videos when we were doing the whole, modified stats thing, let me go ahead and put in a breakpoint here. Let's say I was maybe, adding some things in and I wanted to test out, what happens when I step through my code when I say, apply a new stat modification to a character. So let's just go here. I've just put in that little breakpoint here. You see this little red dot. Basically, again, all I did was just click to the right of the line number and to the left of all the actual code that's on there. So now we'll actually come back over to Unity. Let me go ahead and hit the play button, and then I'll trigger one of these stat modifications. And you'll see that, well, actually nothing happened. So if you're familiar with breakpoints, basically what's supposed to happen is that there is a break in the code, and then it actually pauses execution and you can kind of step through things. Now, the issue in this case is because we are using the burst compiler. If you go up to jobs and burst, you'll see that enable compilation is enabled. Basically, we want that for most cases because it's going to give us the best performance for Unity ECS. However, if we actually disable this, it will fire that breakpoint. But maybe we don't want to just completely disable burst throughout our application. Well, in that case, we can just go to our entities.forEach and we can just add the without burst here. So now when I hit the play mode, you'll see that I do enter play mode. I can kind of move around and attack, and then when I execute one of these stat modifications, you see that it immediately flips me back over to the IDE. You'll see that this kind of bit of code here has been highlighted because that breakpoint has now been triggered. Now, the fantastic thing about this is we can actually say, like hover over something like these base stats, and I can click on this plus button and I can see, what the character's base stats are. It says the attack damage is 10, the move speed is 5. We're gonna be calling this modify method here. So of course, we can hover over all these variables, but critically, we can also step through things. So we can either choose to say do a step over, which in this IDE use F10, which basically brings it to the next line of code in that current method there. Also, we could do something which is a step into, where we actually step into the method that's being called. So in this case, we're doing the dot set as total components. So if we do a step into, it's going to take us right to that method. And then from in here, then again, we can do the same thing. We can do a step over, and then we can see, how the data is changing as we step through our application. Again, we can kind of, hover over these things and see, what is the total move speed here. And then of course, when we do a step over and a step over, it'll bring us back up to here. We can again kind of compare that with the base stats where we had a move speed of 5 and now the move speed is up to 10. And then of course you can get really crazy with this. You can go into and get an idea of what Unity is actually doing. So if we do say a step into on the remove component, then it's actually going to bring us into these remove component calls. And let's continue doing a step into here. You can really go deep and see what are all the things that are happening when you're using some of these ECS methods. And you see there's quite a bit of stuff going on that it ends up going through just to do some simple operation like a remove component. Anyways, once you've completed your fun, basically you can say resume program, and that will basically just continue resuming the program. It's going to continue executing. If we come back over here, of course, we can move things around, but the breakpoint is still going to be active. So if we say, trigger another like stat modification, you'll see that the game is paused. I can't actually do anything in it. And then if we come back over to writer, you'll see that I have broken out at the same point here. So again, in this case, we did just have to disable the burst compiler. So it is kind of a trade-off that you need to make at this point. Now, the second point that I wanted to bring up that I learned in this interview with John Carmack is the use of live comments in your systems to ensure that they're running properly under specified parameters. Now, I'll get into all what this means in just a moment here, but I do think that this is incredibly relevant for data-oriented programmers specifically. And let me just give you a little bit of background so you can kind of understand why I think that that is. So as data-oriented programmers, we need to make certain assumptions about how our application will run in order to figure out, what optimizations that we need to take. So let's say, for example, we have some type of system, and this system has, maybe a couple different cases that, an entity could particularly fall under, which will determine, how the implementation of that particular system works. So let's make the assumption that, say, case 1 is the most common use case, because this is, what a large number of entities are going to be very frequently doing throughout the lifetime of our application. So we'll make a bunch of design decisions and data structures and our systems, basically kind of, optimize them all in such a way to be most efficient for case number 1. However, we also have case number 2. Now, case number 2 is also a very important one. It kind of handles some of those edge cases that are not happening quite as frequently, but we still need to handle them just so everything kind of functions properly within our game. So now, just kind of for the sake of argument, let's say, the way that we've structured and chose to optimize everything for case 1, that means that, naturally case 2 is going to be kind of unoptimized. Maybe there's a bunch of structural changes that have to happen, or referencing other places in memory, and it's just leading to a lot of cache misses. But that's okay, because again, case 2 is kind of the edge case scenario. We know that it's not happening as frequently as case 1. And, again, when we start kind of developing things out, this is totally fine because everything's optimized for case 1. So case 1 performs super well. And then case 2 still works. It does what we need it to. And it doesn't matter that it's not optimized because it just doesn't happen that much in our application. However, as many of us know, things change over time throughout the course of game development, and what is uncommon today may end up being the common case tomorrow. We may not realize that a system which we previously assumed to be uncommon is actually happening a lot more frequently than we thought. And by the time that we realize this is affecting our performance, it may be too late to do anything about it. Now, one poor practice that developers may end up doing if they find themselves in kind of a situation like this, and trust me, I'm definitely guilty of doing this myself, is to just put a static comment at the top of the class file saying something along the lines of, Important, this system is not optimized and it should only be ran on a few entities. Now this doesn't really actually do you any good, because the only way you'd know that there is an issue with that system is you'd have to, manually locate and open the class file. You'd have to notice and read that comment. You'd have to interpret the possibly vague message that may not have even been written by you. And then you'd have to be expected to know that the program is possibly failing to meet the criteria hinted at by your comments. A better solution would be to use something like a live comment, where you can actually do some checks and balances within your system to ensure that your system is kind of running under some specified parameters. So if you assume that, say, your system should only run on no more than 10 entities per frame in the absolute worst case scenario, maybe you have a check to see if your system is ever running on 50 or more entities. And if it is, then you get a nice little warning message that you can just click on and it'll bring you right to the system that you'll be looking at. And then from there, you can determine, how to re-optimize it, or if it's even necessary to optimize. Maybe you just kind of look at things and say, hey, it's still running smooth. Let me just go ahead and increase this warning number to 100 entities now. And the really great part about these live comments is they'll be constantly running as you're testing your application, so that, if you're ever in a scenario where one of these, live comments basically triggers, you get a notification right away. And again, you can just go and investigate that right away, and you don't have to, worry about some, possible things coming up far down the line where, you could have fixed it a lot earlier on. Okay, so now let me give you a quick example of a live comment in an ECS project. So I'm just using this same modify stats system here. And then this time you'll see that what I'm doing is I have a private entity query that is a part of the modify stats system. And you'll see down in my job here, I'm doing a with store entity query in field ref player query. So that basically just gives us the query that this for each returns here. And then basically using that player query, we can actually do a calculate entity count. So in this case, we know that, we only want this to run on one player. Typically you wouldn't do this exact way. Maybe you'd have some, very large number that in theory that your program would never hit. But in this case, let's just do a quick validation to say if the player query that calculate entity query count is greater than 1, let's just go ahead and give us this little debug.log warning here. Now, if we come back over to Unity and we just kind of, play around here and we go ahead and, add power-ups, our game is going to continue working and playing like nothing happened. We're not getting any messages in the console or anything like that. But now let's say we go ahead and duplicate this player. So now we have 2 players in the game, and actually if we're moving around, it's going to move them both around. Now, what happens if we actually try and apply a stat to them? Well, it's actually going to continue working, but we now do get this little error message in the console saying, warning, there's more than one player in the game. Check this system for performance. So now we can just go ahead, double click on this log warning. It'll bring us right to that specific place in the code. And now we have the exact system that we know we need to, check for performance, or, maybe we need to rethink about how we implement it because it's working a little bit different than we initially thought that it would. Maybe we just do a little bit of testing and we say, okay, it works great with 2 entities. It should probably work with like 100 entities. Why not? Maybe at that point, maybe we need to kind of revisit our performance metrics or something like that. So this is really just kind of like a hint to say, hey, there are, maybe some things that you need to look at in here. Also, by the way, if you are concerned about performance, because I know that, doing a calculate entity count, it doesn't just like return the number that fit from this player query. We actually have to do a little bit of a calculation method. So if you are concerned about performance, I would recommend doing something like a preprocessor directive where we can just say if Unity editor, only run this if we're in the edit Unity editor, and of course end that if right there. And so with that, I'm going to wrap up today's video. Again, those are just 2 of the many thoughts that John Carmack brought up in this talk that he did with Lex Friedman that I find particularly relevant and actionable towards my Unity ECS development that I am going to start implementing pretty much right away. I was actually doing a little bit of it this morning. Once again, I highly recommend that you listen to the full interview. I've just been kind of like listening to little pieces of it at a time as I've been driving around and taking care of chores and things like that. But again, very, very riveting conversation between 2 incredibly smart individuals. Don't forget to check out the Humble Bundle and the link in the description below. Lots of cool stuff in there. Again, best deal in game dev right now, in my opinion. Finally, if you did enjoy today's video, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system and their data-oriented technology stack. Of course, if you do have any questions or suggestions for future videos, you can always leave those down in the comment section below, or come join us over on Discord over at tmg.dev/discord. Anyways, I hope you all have a fantastic rest of your day, and I'll see you in the next one.